Welcome to today's webinar. Today we are looking into the BGP communities, a feature of BGP that is often overlooked by small networks, but is incredibly valuable once you understand it. So knowing about the BGP communities and how to use them can make managing the BGP sessions and prefixes much easier. So in today's session, I'll be presenting on the concept of the BGP communities, and I'll show you some practical examples on how they are used in the internet. Today we are going to talk about the BGP communities, and but first a quick reminder. So the border gateway protocol is a way that routers on the edges and different networks talk to each other. And when two networks connect, they exchange information about the IP addresses they can reach using external BGP. And one router shares its information with the other routers and adds to its routing table. So in our last webinar, we discussed on things like the next hop, the best path selection in BGP. Okay, so you don't have to worry because these topics aren't needed to actually understand the BGP communities, because BGP communities is a separate topic altogether, which was added up later and weren't a part of the original design when BGP was actually implemented. Let's talk about BGP prefixes. A BGP prefix is an IP address or a range of IP address that you can see here that the BGP routers share with each other. And each BGP prefix comes with several attributes like the next hop IP address, then the ES path length, then others such as the origin, the metric, and the local preference, which we discussed last time. So in addition to this, BGP prefixes can have optional attributes. So these might look like large numbers on your router, as you can see over here. And this is what we call the BGP communities, which is the topic for today. So what's in a number, you might ask. So if you can take one of these BGP community numbers and write down into hex notation, it looks something of this sort. Okay. But when you split those two parts and then change back it to your regular numbers, you will notice something interesting into it. And the first part of this often looks like an AS number, and that's exactly what it is. So nowadays BGP communities in your router are shown as 16-bit numbers. The first part of the number is usually an autonomous system number, but where do these communities come from and how do they get attached to these prefixes? We'll see. Let's look an example of a network plan with a few networks announcing their prefixes using BGP. So imagine this is a prefix that is being announced from one router to the next. So before sending it to the router adds a BGP community to the prefix and then it forwards it to the next router. So the next router in the line might decide to actually remove the community before passing it on, and routers can easily add or remove these BGP communities. So how easy it is, it's depend upon actually your router vendors, depending upon your router vendors and your BGP setup. So adding the BGP communities is usually a straightforward thing, but not all routers make it easy to remove them actually. So what are BGP communities useful for? So you can imagine a suitcase covered with stickers. So each sticker might have a special meaning to the owner. So similarly, BGP communities are also like stickers for BGP prefixes. You can stick a community onto a prefix and pass it along. And someone else might add another community or remove the previous one, just like how stickers can be added or removed from a suitcase. What you can use BGP communities for? So they are actually very useful for adding some extra information to the BGP prefix. For example, you might use a community to show where you have received the prefix. Like I have received this prefix in Europe and I got it from a router from Frankfurt, or I have received it from DE-CIX. So BGP communities lets you attach these kinds of extra detail to a prefix. So BGP communities aren't just for geographical information. You can also use them to show how you received those prefix in such a form as from an upstream provider or a peering connection or from a customer. So you can even combine the different details, like saying you received the BGP prefix in Europe, in Frankfurt, via a pairing of DE-CIX. So BGP communities lets you express all this information. Let's come to the next slide. So how do you encode this information basically? So a BGP community is a 32-bit number, which is split into two 16-bit numbers. So One common method is to use the first 16 bits for your autonomous system, the ASC number. For the second 16-bit part, you can encode additional information. So think of it like this, like each 16-bit number ranges from 0 to 65,535. So you can use the first 16 bits to represent an AS number and then use the rest of the 16 bits to encode some other details, like you can use digits or codes. For example, you can use one part as an AS number and the other part for specific information from where the prefix was received. So to encode some geographical information in the BGP communities, we can start off with a simple example wherein you can use the first digit. In this first digit, we are just using as 1. So 1 you can use to represent as the community to encode the geographical data in it. Okay. So this is just a starting point and you can certainly develop your own encoding scheme. I'm just using these values just for reference and for example. Okay. Then we come to the second digit. Then second digit you can use to represent a continent since there are fewer than 9 continents. So a single digit also would be viable for this information. Then the remaining 3 digits also you can use to encode the country as well. So in this case, I have used the ISO numeric code that for every country we have. For example, you can encode the country where the prefix was received with the last 3 digits of the ISO code. So remember, this is just an example. You can create your own solution that fits your requirement for your network and you can encode your information based on your preference. You can apply the same method to encode the logical information also in the BGP communities. Just for instance, you can use the first digit as 2 to indicate this community represents some sort of logical information. And this digit serves to identify that the encoded value refers to the type of relationship that the prefix was actually received. So in this case, such as I have mentioned, it's received from a peer or from a customer or from an upstream provider, for example. Okay. As by using this approach, you can distinguish between different types of information, the geographical information and the logical information within your BGP communities. So BGP communities can be used for much more than just adding information to make it easier for an operator to actually identify where a prefix was actually received. So they can also be used to instruct routers on how to handle these prefixes. So for example, you can use BGP communities to define whether a prefix should be announced to the customers, to the peers, or to the upstream providers, or even more granularly, you can tell specific locations like DE-CIX also. So we refer to these types of communities as an action communities because they tell the router what to do with a BGP prefix. So there are several predefined action communities also, like I said, that are well-known action communities. So which were defined by the RFCs and the internet standards. So one of the most widely recognized is the no export community. So if a BGP prefix has a no export community set, then it indicates that the prefix should not be sent to any external BGP neighbors. Okay. So this is particularly useful if you want certain prefixes within your own autonomous system and should not leave the autonomous system border and should not be propagated to outside of your autonomous system. Then we have one more, another well-known community, which is called as the no advertise community, which means that the prefix should not be advertised to anyone, not even via the IBGP neighbors also. So there's also one more no peer community. Although no peer community is rarely used in practice, but you can also use it for example or for your reference also. In this case also, it means that the prefix should not be sent to any of the peers. In addition to this, most providers define their own sets of communities to control their traffic announcements in various ways. For example, if there is a black hole community, so that instructs the router to discard all the traffic that is destined to a specific prefix. So this community usually implies the no export in general, and if you don't want to propagate, so it just black holes the routes beyond your network. So DE-CIX was actually involved in defining the standards for particularly this black hole community. So again, let's go back for to the encoding for the BGP communities. So keep in mind that you only have 16-bit numbers available. So here are some ideas for using the action communities. So for example, If you are a transit provider with customers using BGP, you can allow them to send specific actions by instructing them to use the autonomous system number in the first 16 bit of the field and define the set of allowed commands to it. So, however, it's important that if you permit customers to send this community, you should restrict them to a specific set. Any other communities they send should be filtered or scrubbed upon the entry. By default, router's behavior is also in such that even if it receives any community and if it is not being configured to pass on that communities, it is always going to scrub if it receives a community from a neighboring router. So you don't want any customers to send any unauthorized commands to the routers. So that it might seem obvious, but some people often overlook it. And this is a safeguard mechanism that you can opt for actually. So possible actions you can permit include your customers to control whether their prefixes are to be announced or not to be announced to the upstream providers or to the peers or to the customers. So you might also allow them to define some more granular options if you configure it, like announcing a prefix to only certain regions. So example, Europe or US, or announcing the prefixes with a longer AS path, or modifying the local preference for the prefixes. And of course, black holing is another example of using these communities for your customers. So let's look at our encoding example. So we have already used the 1 and 2 digits in the previous example. So in this example, let's start with 4. So here 4 will significantly signify the control of the announcements, and the second digit will specify whom the prefix should be announced within the 1 digit. You can encode options like customers, peers, upstream providers, or any of the combinations of this. And the last 3 digits you can then use to encode the specific countries or specific regions that you have where this prefix should be announced. Okay. So this approach actually allows a flexible and more granular control over the BGP announcement based upon the needs and your downstream customers. So far I have discussed using 16-bit numbers for the BGP communities. So often suggesting for placing your autonomous system in the first half of it. But however, you can see the modern networks, the ASNs are frequently using the 32-bit length ASN. That's the 4-byte ASN that we have. So there isn't any way of fitting the 32-bit ASN with the additional information in the original BGP community format. That was the standard BGP community format. So to address this issue, in the RFC 4360 was introduced with the extended communities. So in extended communities offer several new capabilities. So first they allow us to encode the 32-bit ASNs that we generally use in nowadays. And they also include a type field for additional features also for providing more flexibility and granularity in how your communities can be defined. So in this example also you can see how it is. So I have shown this extended communities introduce several new bits including the INA bit. In this bit indicates whether the community is a well-defined one, making it possible to distinguish between the well-known communities with just a single bit. Then there's a transitive bit which signifies whether this community should be retained or forwarded to the next autonomous system number. So if it's a non-transitive one, so the community should be removed and before forwarding to the prefix to the another AS. And additionally, we have a type field also. So this type field can either be an INA designated or an experimental also. The RFC provides a complete list of these types to refer. So extended communities have a 42-bit value field consisting of a 32-bit ASN value and a 16-bit value. Okay, so this format was standardized in 2006. But however, extended communities also never gained the popularity. One reason being that they could not accommodate 32-bit numbers with the 32-bit ASNs because it was the entire set was only of a 42-bit length. So these limitations actually created a need for some type of a newer community to it. So the notation for the extended communities is quite similar to the original format, but we see some key differences over here. It begins with a type field, like I said, followed by 32-bit ASN and a 16-bit value. So the results are total of a 42-bit value to it, and meaning that you cannot have both a 32-bit ASN and a 32-bit value in the same community because obviously the length is only 42-bit. So the type field could represent different purposes, such as the route target or the route originator, which often led to confusion among many operators. So like I mentioned earlier, also the another type of community was needed. So it actually took IETF quite a bit of long time to actually implement this. But finally, after 11 years of hard work, they came together and defined what we know as the large communities today. Large communities simplify these things by taking us back to the straightforward approach. So they consist of a 32-bit value without the complexity of the INA bits and the transitive bits altogether, or any other type of the flags that we had previously. So just three simple 32-bit values we have. The first value that we have is the global administrator, which is a 32-bit value for the ASN. Then this is the entity that gives the meaning to the entire community. Okay. Then we have the remaining two values known as the local data, which can be interpreted in different ways, simply as to 32-bit values with the function and the parameter value to it. So this approach allows the functionalities of the original BGP communities, but with the 32-bit ASNs as well. So this flexibility, including to represent the 32-bit ASN added, which was there, helped to actually develop a larger set of communities with more flexibility and versatility. Let me explain how DE-CIX uses the community on their DE-CIX route servers to control the re-announcement of these prefixes. So the default behavior of the route server is is that when you announce a prefix to it, the route server will automatically re-announce this prefix to all the connected BGP customers. But however, DE-CIX allows you to use specific communities to direct how your prefixes are re-announced, giving you a greater control over which customers receives your prefixes and under what sort of conditions you want them to have those announcements spread. Okay. So this is the default behavior. You can see in this animation that when if a customer announces a prefix, it's automatically get announced to all of the customers. Okay. So in this next example, let's say you don't want your prefix to announce to anyone except for a specific AS. To do this, what you can do is to have a combination. Okay. You can have a combination wherein here how it works. The router will receive the prefix. Okay. And then these two communities you can add up to. So don't announce the AS and announce to a specific AS. So the route server will receive the prefix and these two communities will then re-announce the prefix to the specified AS, blocking it from the others. So I believe that animation was not working properly, but still in this it was don't announce to any other ASN. In this next example, you can also choose to announce a prefix to everybody except for a specific ASN. To do this, use a community that tells the route server to re-announce the prefix to all the participants except for the one ASN that you have specified. So when you use this community, the route server will re-announce the prefix to the everyone except for the ASN that you have defined. So in this animation, the one that you intended to is only receiving the prefix and the rest of the people are not receiving that prefix. So in this example, on the left hand side seeker, these are the three different examples that you can see. The upper one is generally for the standard community, then we have the extended one and the large ones. So in this example also you can see if you don't want this prefix to be announced to AS65501, so it won't be announced to that particular ASN and gets propagated to the other ASNs. So here's a summary. So BGP communities can be used to add extra details to your prefixes such as their origin, their logical information, and this makes your prefixes easier to understand. Then you have the controlling actions that come with it. So BGP communities can also direct your routers on what to do with the prefixes, deciding which ones to announce and which ones not to be announced. So if you haven't used any BGP communities yet, you can start using them in your own network, in your lab setup. So adding the geographical information and any of the sort of values that you want, and have a test setup to see how it goes and how the prefixes are propagated and blocked in your local network. And some controlling actions that you can apply, like I said, that there's no export black holing policies, then there are many more to it. So make sure while setting those PGP communities in network, you uh, plan and work correctly before implementing it. Like I said, you have to think before and plan before you use those controlling action BGP communities to it. So thank you everyone. So that was the presentation. We are open for any questions that we have from our audience. Generally in ISP networks, people don't prefer to use this BGP communities because they are far too complicated also. And ISPs generally don't require them because they don't have much of those internal routers propagating their customers router and give actually ISPs don't give a preference to their customers to actually have some sort of those sort of manipulations to actually happen, to have some transit providers or to have some local preference or an AS path reference to it. But these are generally opted in the internet exchanges wherein we want our customers to actually have those flexibility because earlier times there were no concept of actually bilateral sessions over the internet exchanges where only routes were propagated over the route server sessions. So in that time to give them some sort of control and route leaking was happening. So this actually BGP communities helped a lot to the customers to actually opt for to whom they should announce their prefixes or not. But in today's time, most of the major CDNs are opting for bilateral sessions or they are decommissioning their sessions from the route server. So the customers are having more granular control over the bilateral sessions rather than a route server sessions. But people still have a flexibility to use these communities over their LAN networks also. So I think today people are not having any questions. Might be they are not using communities in their network yet. I'm sure people are using in DE-CIX and internet exchanges extreme, but still we don't get much request or any help regarding communities from customers because it's the least approach that they are taking to because by far ISPs are not looking out for such deep level of configurations on their routers. Bilateral itself is a BGP configuration is a deep level topic for them for newer ISPs.
What is the difference between site of origin and route target? ST and SO.
Site of
ST and
origin and
RT.
route
Yes,
target.
site of origin and route target. RT and SO.
One second. These were actually features that were provided earlier in the BGP community. So I'll also have to look into the RFC actually. So what were they implemented for actually? These are not actually used actually in the first place.
Okay. And suppose if someone
Yeah.
is sending me no expert a community with no expert,
Yeah.
can I tweak that community and send to the other peer? Am I able to rewrite that community which is
Yes.
sended with?
Yes,
Okay.
you can transmit those communities to other your routers as well. So for instance, you have one customer, okay, and you have another router connected. Okay, there's a three router setup you have. One is the customer's router, one is your router, and one is another router. Okay, so what you want to basically do is have the customer is propagating some communities, and you want to transmit those communities to the other router who is actually tagging those communities and doing this routing on the edge level. Okay, to the other autonomous system numbers or the other IBGP peers. Okay, so the middle router that you are having has to have a configuration set in the BGP process where you can have a send community tag to it that's in the BGP process wherein it only accepts those communities and allows it to be transmitted to the other border routers as well. You have to set it. Even if you don't physically map those BGP communities on your routers, you can use a send community target to it so that those communities which are being given should not be scrubbed in the first hop itself. It would be transmitted to the other neighbors as well.
Okay. And in Looking Glass, wherever I search my prefixes, it shows me the strain of communities.
Yeah.
Is there any way to track those communities so I can know that where my routes is propagating from? Let's say is my route. Am I searching from Looking Glass in America? So
Okay.
is there any way that is that my route is via Singapore and then America or via Europe?
So
By
in that
looking
case,
community only.
yeah, in that case, there are looking glasses which are sometimes provided by the transit providers. Okay, in their looking glass, you can have a look into where actually your routes are being propagated. That is not available to everyone, but some of the transit providers have those functionalities wherein they have some sort of looking glass where you can see your community tags being propagated to which transit providers and which continent paths they are taking to. In DE-CIX case, you can have a look into the LS looking glass or in the IXP looking glass as well. So in general, when customer announce it's a all export community that is been attached to it, so it gets attached to gets announced to all of the peers. But if you are specifically matching some sort of a BGP community to it, you can very well see in the looking glass that you are exporting this community and it is being fetched by us. So I believe no more questions there from the audience. Prepend path effect in BGP. So in BGP prepend also you can implement with local preference also in BGP communities. If you have your router accepting a particular route map, you match those prefixes you receiving from your border routers and have a tag defined where you specify a local preference value to be set to an outbound router so you can manipulate it. Also prepend can also be applied, depends upon your preference. So that's what you have to actually do a test setup in your lab and have to figure out. But whenever you have those sort of configurations running, you can clearly see in the BGP routing table, BGP table that whenever you receive it and prefix, it's getting tagged with the proper community or not in the show IP BGP table with a particular prefix. I believe we are good to close this meeting. I would request our audience to like, share, and subscribe our social media handles on Facebook, Instagram, LinkedIn, and do drop your LinkedIn profile names into the chat box so that our marketing team could reach out to us for special offers and updates on the next sessions as well. So thank you everyone for joining this session. We'll see
Thank you.
you.
Thank you
Catch
so
up.
much, sir.
Yeah,
Thank
we'll
you so much.
catch you up in the next one. Thank you.
Thank you for watching.